All right. Well, good morning, everybody. So, multiple things to go over today. Any questions before we start? I'll try it with my microphone on. How's that? Yeah, so let's definitely talk about ODP 402, and then we'll talk about 403, and we'll go from there. And I posted a homework too, which is due Friday morning. So let's talk about the ODP first. First thing to note, so the goal in this ODP was to write a bash script, not a C program. And about 12 people turned in C programs instead of bash scripts. And I'm not going to go back and change the grade, because if the assessment gives you 10 out of 10, you get 10 out of 10, okay? And if you did a C program because you didn't understand that you were supposed to do a bash script, that's fine. Do a bash script from now on when it says, submit a script. But if you did it because you didn't know how to do a bash script and you decided to get the points anyway, you're missing the point of the ODPs, okay? The point of the ODPs is to bring you up to speed on something that you might not know how to do, so that you'll be able to do, other things that build on it. So let's talk about that ODP. And a couple of people saying there's no homework too. Now there's a homework too. All right. It's not enough to publish it. You have to publish it twice. All right, so ODP 402. So the goal was to write a script that would accept a number from the user, double it, and then print out that doubled value. So read one line of input from the user, take it to be an integer, multiply it by 2, print that out. Right, that's enough to get it done. So read is the keyword that says I want to read something from the user. Read is followed by the name of the variable you want to read into, and then this will take the value of that, multiply it by 2 as a number, right, and print that out. And you can mess with this from the command line, right? So if I say read num and I type in 234, I can echo $num and it's 234. If I echo $num times 2, it's 468. So some of the things that I saw people having trouble with, not making your script executable. I think I already made this executable. But if you start a new file, by default you can't run it, so you have to change the permission bits. Okay, that's one thing. Doing something like read $num will get you into all kinds of trouble, because $num says I don't want num, I want whatever num is equal to. So if you're starting with a new variable and you say read $x, and I type in something like 23 and I echo $x, x doesn't have a value. I did not read into x, I read into whatever the value of x is right now, which is nothing. So I just did a read statement with no variable specified, and whatever I type in, it doesn't go anywhere. All right, so So a few comments on that. One, you should be writing your script and testing it from the command line before you assess. By the time you're assessing, you should be pretty much 100% sure your code works. And lots of people, wrote their script and assessed it, wrote their script and assessed it, changed their script and assessed it, and probably never ran it from the command line. Because in some cases, if they ran it from the command line, they would have gotten a permission error, or they would have gotten a syntax error, or they would have seen that it just plain doesn't read a number and print out twice its value, right? So think of this as your final exam programming assignment that determines if you pass the course or not, right? And forget about assess. Pretend you're writing this code and you turn it in and you've got one shot at it, right? And once you give it to me, that's it. I'm going to try it, and if it works, you get $1 million, and if it doesn't work, you fail the course. Okay? Think of it in that mind. Don't stress yourself out. Think of it in that mindset, right? Write the code, test it again, test it again. Think some more about other ways that you can test it. Convince yourself absolutely so that you could say, yeah, I'll bet you $1 million this will assess perfectly, right? And then put it in the assessment system. Because part of what we're trying to do is develop our skills at testing our own code, right? So we want to be able to design algorithms. We want to be able to implement them in code. We want to be able to test them, and we want to debug them. Okay? Those are all 4 important steps. So the testing part is critical because in general in life we don't have assessment code, right? We have to make our own test cases to know if our code actually works before we hand it on to whoever is asking for the code. So do some tests, right, on your script. Convince yourself that it works, and then go ahead and assess it. And then if it doesn't work in assessment, there's probably one of 2 things going on. Either you misunderstood the assignment, or there's something wrong with the way you're assessing it, right? And those are much narrower problems to dig down into. All right, let me look at some questions. So homework 2 is posted now. Yeah, there are other ways you can use change mod. So you can change mod space u plus x, which adds the execute bit to the user permission. But you can also do it just by knowing the hex codes. So if you want your code to be read, write, execute, and nobody else have access, change mod 700 program name will do that. We use curly braces instead of brackets because it's an operation, not a condition, right? Use curly braces where? I'm not sure. Let's see, and I was using brackets for ODP 402 and it worked in Bash but didn't assess correctly. I don't know where you're using curly brackets or where you're using square brackets. So send me some more information or shoot me an email and I can look at that. But I can take a look at your code. Don't put echo $ bracket input. It's just echo $ variable name. And if you're doing paren x times 2, you need $paren x times 2. Got to use parentheses, don't use square brackets. Assess might work. Again, sometimes these things will work, sometimes they won't. You'll get credit from assess, you won't get credit from me. Okay, assess, I basically let it grade it, and unless it's taking away points and it shouldn't have, you'll get whatever grade the assessment system gives you. But on tests and homeworks and stuff, I would want to see $paren, not square brackets. Yes, we will get to putting commands inside other commands with backticks. We'll get to that another time. That's where the magic really begins. Let's see, and yeah, homework 2, you do not have a month to do it. All right, there you go. Homework 2 is posted due October 2nd. That's Friday morning. All right, so ODP 402, hopefully you're squared away on that. If you're running into problems with these scripts and stuff, there's sample code available. Okay, sample code is a really fantastic way, I think, to figure out problems with what you're trying to write. So on the shared code area from Canvas, there's first script examples that we started developing. These were the ones from yesterday where we were playing with command line arguments. But take a look at some of these other ones. So commands. So here's a read example, right? Read variable name, and then if variable name equals, right? And if you're doing read $sign command, that can tell you right there, oh yeah, there's no $sign. Here's an if statement. There's another read example, right? So don't be afraid to click through to code from lectures. Sample code is often a really good way to get back on track with syntax and such. Alright, and someone says, when I tried to run the code, I got an error message saying read and echo were unknown type names. Yeah, so that's something unusual. And I'd have to look at exactly what you were putting in for your code. Maybe they were uppercase or something, or maybe there were some extra spaces somewhere, but I can take a look at your code. If you're finding weird problems, right, shoot me an email. We talked a bit, and I posted a video on how to ask for help on these kinds of things, right? Don't hesitate to do that. If I'm not available, I won't reply. If I'm too busy, I probably won't reply, or I'll send you a note saying, I can't get to this till tomorrow. But it doesn't hurt to ask, right? Go ahead and show me your code, show me the date, show me how you compiled it if it was a C program, show me how you ran it through the assessment and what you saw on the output. Grab it, paste it in a plain text email, send it to my direct email address. Or come by office hours. Alright, so ODP 403. So this posted 8 o'clock this morning. It's due tomorrow morning. Oh, okay, another question. How do we copy from the terminal? Depends on your environment. So if you're in Linux, I suggest Console, K-O-N-S-O-L-E. It's not particularly better or worse than any other terminal program, but I'm familiar with it. I can tell you how to do things on it. On that, you can go into your options and set it so that by simply highlighting a piece of text, so if I highlight this, it'll go onto my clipboard, and then I can Control-Shift-V to paste whatever I highlighted. So, I can go back and I can grab all of this stuff, and then if I was composing an email message, I could just go ahead and paste that all in. I'm pasting it in VI, but same idea. Someone said you can also send your code on the Discord server, so let me make a comment about that. I would rather people not do a whole lot of code sharing on Discord. If there's a particular piece of your code that you're getting a syntax error on or something like that and you can't figure it out and you want to post that, that's okay. But keep in mind, if you have a whole solution to your program and you post it somewhere and somebody else copies it and turns it in as theirs, and I get two submissions that are exactly the same, you both get a 0. Okay? So be really cautious about sharing code with anybody else. Snippets of code, a few lines, one section that you're stuck on, that's can be reasonable. Okay? But be cautious about that too. But if you turn in code that's identical to somebody else's, generally you both get a 0, and then it goes from there. And you may be able to prove that you were the one who originally wrote the code, and you might get points back. But it depends on where you are and what the course is and who the teacher is and what their policies are. And in some cases, you can get kicked out of a course on a first offense. I won't do that, but it can happen. All right. So let's look at ODP 403. So 403 is similar to 402, except you're reading an argument from the command line and then printing out twice its value. Okay. So my sample program is called good program. So if I say good program 23, it prints out 46. If I say good program negative 100, it prints out negative 200. That's what your ODP should do. So you pick up that command line argument using $1 and just do the same thing you did in the previous assignment. Just multiply it by 2 by saying, echo $paren 2 times $1. So that can be actually a one-line ODP, if you like. All right, so something I mentioned in the other class yesterday, so let's talk about it in this one. This is something called a shebang. So the idea of a shebang is, we know that in bash scripts, a number sign indicates a comment. So anything I put after a number sign is going to be ignored by the shell, right? It's a comment for myself. But there's one exception to that statement. If the very first line of your program begins with a number sign followed by an exclamation mark, then whatever comes after that is taken as the program that should be run to execute your script. Okay, so what does this mean? Alright, so I have a script in my current directory called go, which outputs hello. The reason that this works is because I'm sitting inside a bash shell, right? I'm running a program bash, and bash, when it sees me type something in, will look in my path for something with that name that's executable, and it finds a file in my current directory called go that's executable, and so bash is going to execute that. Well, how does it execute it? It basically reads in each line and interprets it as a bash command. So bash knows how to echo, it says echo. Bash knows how to do arithmetic, it does arithmetic. Okay. If I were not sitting in bash, though, if I were actually in a different shell, like T shell or C shell or the corn shell or the Bourne shell, right, and I gave it a script that contained bash commands, that script might not work. So I might have a script that works perfectly well for me, but I hand it to somebody else who's not running bash, they're running a different shell, and they run the script and they get a bunch of syntax errors. So what we usually do is we make a very first line in all of our scripts which say what shell should we use to execute this program. And for us that's going to be /bin/bash. Now having this or not having this doesn't make a noticeable difference for us because, presumably we're all sitting in the bash shell. But in other cases, right, this can make a big difference. So make sure you put this thing in first, and it's called a shebang. And it's got to be the very first line of your script. If it's the second line, it's just a comment. And, if you have a typo in here, and you say go, it says, there's no bin/bash. Okay, it can't run my script. If that's not the first line, though, it's just a comment, and since there's no shebang in the beginning, it runs the script using whatever my current shell is. All right, everyone okay with that? All right, so let's talk about Git. So, imagine that you are working on a project and you're going to write 10,000 lines of code for this project. And there's 1,000 other people working on this project as well. And together you're going to develop several million lines of code for some large system. Like, for example, you're writing Linux, right? You're developing it. Sometimes you're working on a piece of code that is just your piece of code. It's a self-contained module, and when you're done, you're just going to plunk it into a larger system. But very often, the code that you're developing interacts with code that other people might be developing. Right? All these things are linked together. And so somebody who's working on code B might need access to your current version of code A. But while they're using your current version of code A to develop their code, you might be making changes. And so source code management can be a huge issue. Okay, if you're working on a team, we'll have one group project in this course. We won't have teams of 10,000 people. But, you know, when you're working with other people on code development, it can be tricky to keep track of, you know, who's got what version of the code. What you don't want, for example, is you and I are both working on the same piece of code. We're both making changes. And when we're done, we have two completely different versions of this code. And along the way, somebody else has been working with an old version of our code to develop another piece, and now their code doesn't work with either of our versions, right? So we'd like a way to be able to manage large projects where we're doing code development across a number of people, a number of teams, and have some way to keep track of stuff. On a more individual scale, we'd also like to have a way to have backups of our code. Okay, it's really easy to accidentally remove all the files in your directory, and unless you set up all kinds of well, no, unless you set up things to like ask for confirmation every time you delete or something, it's really easy. You think you're in one directory, you say rm-rf*, but you were in a different directory, and your code is gone, and it's not in a recycle bin. It's gone, right? You got to go back and rebuild it from the hard drive structures, perhaps. So you would like to have backups of your code, and nobody likes doing backups, but we need to do that, and you need to do that even for stuff that's on the server, because the server linuxengrcs.com is not backed up. Okay, I don't maintain that server. It's a company I pay a few bucks a month to run. You got to do your own backups. Okay, and certainly on your own machine you need to do some kind of backups, because hard drives fail and mistakes happen. So we want backups of our code. It's also nice to be able to keep track of different versions of our code. Sometimes you got a project that's working almost perfectly, you got one bug left to fix, you go in and you try to fix it, you make changes for a couple of hours, and now you try to compile it and nothing compiles. And you're getting screens of errors and all this kind of stuff, and you'd love to go back to the way that your code was before you did all of this fix, right? So we'd like to have versions of our code. And also sometimes it's nice when you have a piece of code that's working to say, hey, let me try something, right? Let me start making some changes and see if it works. And if those changes work, I want to make them permanent. If not, I want to leave them aside and come back to them later. So all of these things can be managed by a source code management system. Okay? So when Linux was being developed, the team was using a source code management system that was free, which was good because this was, you know, an open source project. And partway through the project, the people running the source code management system decided it was time to start charging money for it. And so they announced you're going to have to pay, you know, fees to use their source code management. And this was a disaster because all of the code that was being developed was in this source code management system, and suddenly you had to pay money for it. Okay, so Linus and the development team basically built their own source code management system in response to this. And the system is called Git, G-I-T. And it is widely used It's extremely convenient. It does what it's supposed to do, and it does not get in your way for the most part. Okay, once you have it set up and you know a few basics about using it. Now, until then, it's a pain. It complains, it gets in the way, you have to deal with it, okay? But that's the learning curve part. It's a pretty small learning curve. And once you're comfortable with Git, it's just there. And it takes you, 5 seconds to check in your code, and bang, you've got, backups, you've got version control, you've got a way to go back and look at old things that you did, you've got a record of all the changes you made, and so on and so forth. So, so we're going to work with Git in this course, and I had this all ready to go. Here we go. All right. So if you look at the how-to on Canvas, the quick start guide, how-to guide, there's a whole section on Git. So I pointed you to this yesterday. So Git and GitLab. Okay, first of all, Git and GitLab are different things. Git is a source code control system that you can use on your own Linux environment. You can use it on the Linux server, and it's all local. Okay, so nothing to do with the cloud. It's making copies of your project in your current directory, which means if your hard drive fails, you lose your repositories. If you accidentally delete your entire directory, you lose your repositories. Okay, so it doesn't help with disaster recovery, but it still helps with, keeping versions of your old code, tracking your changes, and so on and so forth. GitLab is one of a number of cloud services where you can push your Git repositories, your records of everything you've done, into the cloud. Okay. GitLab is free. You sign up, you give them your email address, they don't seem to spam you. But it's effectively unlimited storage. They will give you 10 gigabytes of storage per project for free. Okay. They let you have private repositories, which is important because you don't want to push your projects that you're working on over to GitLab and have everybody else in the class be able to look at them. So you have private repositories. And it's stable, it's been around for a long time, it works, it's widely used. Okay. GitHub is an older, I believe, version of a Git cloud server. Extremely popular, heavily used, and then Microsoft bought it. Okay, so a lot of people jumped ship when Microsoft took it over. It works well, a lot of people still use it. Originally, GitHub did not let you have private repositories unless you paid money. So that's the reason I've been using GitLab for this course. That may have changed at GitHub now, but nonetheless, we're still using GitLab in this sequence of courses. So if you don't have a GitLab account, you want to get one, and I suggested yesterday that you did that in time for class today. So we'll play with Git first, and then we'll hop onto GitLab if time permits. We should have some time. All right, so advantages of GitLab, well, that's what I've been talking about basically, right? So free storage, backups of your code, ability to make branches where you can have different versions of your project, and so on and so forth. So 3 things you have to do once, okay? In the very beginning of your life with Git, you have to do these 3 things. You have to set up your username, your email, and unless you like Nano, set up your editor, okay? So, I'm going to live dangerously. Oh, I can't do that. Okay, so let's just go ahead and do this. I'll put this over here. All right, so I'm going to log in as a different user because I already have Git set up for myself. So I'm going to log in as my test user. Okay, so first command, git config -- global user.name, and I'm going to put in my name. I'll just be Nick someone. Okay, git config -- global user.email. Alright, spam me at spam.com. That's in case somebody random is watching the video. And then set up your editor. So git config -- global.core .editor, and I'm just going to go with VI because I like VI, but I made typos. All right. Yeah, spam me quickly. All right, that's something you have to do once, and it will remember your setup, right, forever based on your login. Okay, so for this account that I logged into, which was my username test, right, this stuff is set up. How is it set up? There's a hidden file on here called gitconfig. And inside gitconfig, this information is stored. Generally, you don't want to mess with this file outside of git, okay? But those git commands set it up. If you're doing this on your own Linux server, git may not be installed. Okay, so sudo apt install git will put it in. And if you just say git and it's not installed, Linux should tell you type this command to install it. So apt is the package manager for installing software. But more often than not, git's installed already. Alright, so our one-time setup is done. Okay, anytime that you start a new project, you need to do a few things. The first thing is you want to go into a new directory. Do not, under any circumstances, do all your work in one directory. Okay, if you're doing ODP 402 and you're going to put it under git control, put it in a separate directory. If you're doing homework 2 and you're putting it in a separate, in git, do it in a separate directory. Okay, separate directory for every project. Because when you put something under git control, pretty much everything in there is going to get glommed together. And if you have multiple projects in one directory, it's going to be confusing. You're going to get tangled up, you're going to step on yourself, you're going to change files that you didn't mean to change, and so on. So let's say I'm working on homework 3. I'm going to make a directory homework 003. That's going to be your first big programming assignment. I'll post it at the end of the week. Okay, make dir makes that directory. There's my homework 003. I'll go into that directory. There's nothing in here right now. All right, so your first command is git init. And you do this once per project. So you make a directory, go in that directory, say git init. And that's it. You've created an empty repository. That's all the setup you need. Okay, we're in here, everything is set up, we're good to go. I can say git status and I see some stuff. Okay, if I wasn't in here and I said git status, it would say, you know, there's a fatal error, there's no git repository here. Okay, so make sure you're in a new directory and you do your git init. And again, you don't see anything unless you do an ls-a. You'll see a directory called .git. Definitely don't mess with that directory. Okay. Right now it's got a bunch of things in there. There's a .git directory. It's got subdirectories. It's got some stuff in there. You don't want to mess with any of that. Okay. That's the one caveat with Git is if you go into the .git directory and you start changing things, you can corrupt the entire structure in a way that, you know, having 2 years worth of history of your changes and stuff can all like become worthless or unusable. So don't mess with this. That's part of the reason it's a hidden directory. Alright, so we're in here. What do we want to do? Basically, as you're developing code, you're going to do the following sequence. You're going to make some changes to code, you're going to create new files, and so on and so forth. Anytime that you're at a point where you want to save this stuff under git control, you do 3 things. You say git add and the name of the file or files that you want to put in your repository. and you say git commit. You do two things: git add and git commit. And here's the sort of picture of what's going on. So here's your Git repository. Just think of it as a place where all your stuff is stored. Okay. Here's your current directory, and you've got file 1 and file 2 and file 3. Okay. There's a thing called a staging area. And so you make some changes to your files, and you want to put them in your repository. It happens in two steps. First, you put these into the staging area. Okay, this is done with the git add command. And you can put a bunch of things on the staging area. You can take them off the staging area. You can make more changes and put them back on there, and so on. This is basically all the stuff that you want pushed into Git. And then when you want to actually put it into your repository, that happens when you say git commit. All right. So it's takes a little bit of thinking at first, but then it's pretty rapid. So let's do file1.c, and I'll just assume I'm paid by how many lines of code I have. So I'll make a bunch of comments in there. Let's make file2.c. And I'll just get a start on that, and I'll make a readme.md. So readmes are just something that says, you know, don't look at this code, it's not really started yet. So readmes are just things that like tell somebody, hey, you should look at this, there's something in here you should see. All right, so I have a few files on here. I want to put these into Git, okay? So two steps. First step is to do git add, and I can add these one at a time. I can add them all by saying asterisk, but that can be a little sloppy, but I'll just go ahead and do that. I'll add all three of these things. And if I say git status right now, I can see that I have 3 changes that need to be committed. Okay, I have 3 new files, readme, file 1, file 2. Okay, so second thing you do, git commit. So git commit, and now I'm in an editor, and it's asking me to write a message telling me why I'm committing these files. Okay, anything with a number sign in the beginning will not appear in my commit message. It's a comment. Okay, but it says please enter your commit message for your change. Line just starting with number will be ignored, and it's telling me what I'm about to commit, these 3 files. So put some kind of meaningful comment here, right? Okay, just created the repo demonstrating add and commit. Now you can find, you know, entire websites dedicated to how to write commit messages for Git. And when you're working on a project in a team or at a company or something, you'll probably get guidance on what your commit messages should be like. The most common commit messages are things like fixed stuff, added stuff, made changes, or my favorite is just a period, because if you have an empty message, it won't commit. So, you know, you just type a period and that's it. That gets you through the commit process quickly, but it doesn't really help you 6 months from now when you're trying to figure out where the change was that, you know, corrected bug 73C, and all your messages say, you know, bug fix. So put something in that's meaningful to you, and we're done. Okay? So git add, git commit. Don't have to worry about it. Okay, now I make some changes. Let's change file1.c. Let's get rid of all this stuff. All right, so I've made some changes. If I do a git status, what you'll see is there's a modified file called file1.c. This is a change which has not been put on the stage yet for commit. And it even tells me here, add file if I want to put it on the stage. If I say checkout dash dash, it will discard these changes and I'll go back to the original version of file 1. Alright, well I want to do this, so git add file 1.c git commit. So this was my initial main module, and I'm done. Alright, so tucked away underneath that .git repository, that hidden directory, is the whole history of my changes, the different versions of it, the commit messages, and so on and so forth. To me, I just see, you know, 3 files that I've been working on. But that other stuff, that structure is there, and it can save you. Let's see. Yeah, you could do a running story in your commits. Will git add commit save directories? Yeah, it will. So if I have subdirectories under here and I add them, they'll get pushed into the repository also. Which leads to the temptation to just put your home directory under git control and just always, you know, git add star git commit. You can do that, but if you want to go back and get versions of your code out of that, that's not a good structure for it. But if you have subdirectories that should be, you know, included in Git for whatever reason, yeah, they can get pushed into the repository. All right. I can also do git log, and I can see my whole history. Okay, so git log will show me, you know, Nick someone on this date checked in the initial main module. On this date and time, they just created the repo demonstrating add and commit. Right, and there's a tag here associated with each commit that you can use to go back to previous versions. Okay, so you can check out based on this tag, and you only need the first few digits of it to specify a version. All right, so that's all you really need to know. Other than if you're going to remove a file, use git rm. If you're going to rename a file, use git mv. Okay, if I just remove a file, like if I remove readme.txt, readme, and I do a git status, it says, hey, I deleted this file, and that change is not in the repository, and it tells me use git add or git remove to update what will be committed. All right, so this gets you running. It gets you a repository. It keeps a history of your changes. It tracks what you're doing, right? And when you submit your code, right, I can do a git log, and I can see how you've been working on your project, right? And if you had your project working really well and then you broke it at the last minute, right, I can look in your repository and you can say, well, it was working really great 2 days ago, right? I can go back and look at the version from 2 days ago and see that. So this is really good housekeeping. It's really good practice, and it's something you're definitely going to encounter. If you go to WSU, you're going to be using Git for everything, okay? And it can get really dogmatic, making sure that you're using Git for every change and what your commit messages are and so on. So you want to get in the practice of this. This is also really good when you're putting together a portfolio to shop for internships or jobs or positions, or you're applying for a program somewhere, right? Having a repository of your work can be really useful, right? Because on your resume you can just put down your GitLab or your GitHub account and you know, a few projects that you're particularly proud of, and somebody can go there and they can look at your work and see what you've done. And that's pretty standard practice. All right, so that's local Git. It gets more interesting when we start messing with GitLab. So GitLab, you have to do a little bit more one-time setup. So the first thing you have to do is make what's called a public-private key pair. Okay? Because we're going to take our Git repository, we're going to push it off into the cloud, or we're going to pull something from our repository in the cloud and bring it back to our local machine. And doing this requires some sort of authentication. And we don't want to have to type in passwords every time you do this. We want to just be able to type one command to say, take my repository, push it into the cloud. So we set up a handshaking using a public-private key pair. If you've done discrete structures with me, you know a little bit about what that is. If not, we'll talk about it in discrete in a few weeks. So you generate a public-private key pair using the SSH keygen command, TRSA B4096 uppercase C, and then put in your email address. This should be the email address you're going to give GitLab. Okay. And when that's done, it will create in a directory under your home directory called .ssh a pair of files, idrsa and idrsa.pub. Okay. So idrsa, that's your private key. Don't ever give that to anybody. idrsa pub, that's your public key. That's the one that you share with people. And it's a big long string. And it's paired with your private key. Okay? Using this string, you can find out if somebody knows what your private key is. But you can't predict what the private key is from knowing all of this. But you're going to take this key, you're going to put it on the GitLab site, and then every time you try to do something with one of your repositories, GitLab will use this key to see if you know what the corresponding private key is. And you'll send the private key over and it can validate and say, oh, okay, you do have the valid private key, you must be who you say you are. Okay, so it's a public key system. So you go ahead, you generate your key with the keygen command, go into your SSH directory, use cat not more to get a copy of your public key, put it on your clipboard, and then go over to GitLab. Go over to, there's instructions here, go over on the left side, scroll down to security, SSH keys, say you want to paste in a new key and paste it in. Okay, we'll run through this tomorrow. We've only got a minute or two left, but we'll run through an example of this tomorrow. Once you do that once, okay, that's one time for the life of your experience with GitLab, as long as you're on the same machine. Okay, once you've done that, you have one more per project step, which is git remote add origin git@gitlab.com : your username / the name of your repository that you want to create on GitLab. And then any time that you've made changes and committed them, it takes one line to push those changes over, git push origin master. So now when you make changes on your project, you have three things to do: git add, git commit, git push origin master. You do those three things, and everything about your project is now saved off on GitLab. And you can look at it from the web, you can pull things back down with a git pull, and so on and so forth. And this is also how you're going to submit your programming assignments. So homework 2, which is posted, take a look at that. It's due Friday morning. But that's basically going through the steps of getting a GitLab account, making a repository, doing your one-time setup, creating a repo, adding me as a reporter on the project. So we'll run through that in detail tomorrow. Okay, but this is enough to get you started. And yeah, somebody suggested ED25519 is better than RSA. So there's more secure versions of this that you can use. All right, we'll leave it there for now. We'll go through the GitLab part in more careful detail tomorrow. But you should be able to get going with Git, okay, and get yourself an account on GitLab. And we'll run through the other details tomorrow. All right, thank you.